I don't want to make anybody mad right here at the moment, but we could have an entire conversation about that. So gene therapy has a really poor record of success in curing diseases because once we find out that the genes are there, those genes are inside of every single cell in your body. So there is no way to fix genes that are inside of every cell in your body. The only way gene therapy is going to cure diseases is if we find out and make sure there are no children ever born with these genes. So then again, there's your question, who gets to decide? So gene therapy difficulties, difficulty getting the working gene into the cells where it's needed. If you think about diabetics, if we knew that they had the gene that was going to give them diabetes, how do we then get the gene into those cells that are important in making sure a person doesn't get diabetes or doesn't get cancer? Difficulty getting the working gene into enough cells and at the right rate to have a physiological effect. So if they fix, say, 10% of my diabetes genes, well, what about the other 90%? So it's hard to get them into all of the cells fast enough to have a difference. Then we have difficulty arising from the transfer organism getting into unintended cells. So if we try to fix pancreas cells by putting these genes into them, what if the genes get into cells that are outside of the pancreas? And then finally, difficulty regulating gene expression. So how do we fix diabetes and get those genes that are expressed in the right way to fix the right disease at the right time in the right cells? It's just incredibly complicated. And that's why medicine is so fascinating and it's making such great improvements, and it's so frustrating because when you think you fixed one thing, then 10 other things go wrong. Getting the transfer organism. So if you're going to fix, like, let's say they're going to try and fix my diabetes. They're either going to fix it using like bacterial cell genes, so the transfer organisms, getting those bacterial cell genes into my cells in the right place at the right time, being expressed in the right way to fix my diabetes. Or they're going to use some other type of cells like human cells. So how do you get another person's human cells into me at the right time, at the right rate? So the question is, where are they coming from? Where are the cells coming from? Are they coming from a pig? Are they coming from a bacteria? Are they coming from another human? Or are they coming from my stem cells? So lots of possibilities, and none of them really work that great at this point. But they'll keep trying, and maybe they'll figure it out at some point. And then, hallelujah, I hope it'll be in enough time that my body is not so harmed from having diabetes that it's like irreparable. It's like finding out that somebody has cancer and then you're able to cure the cancer, but the cancer has done so much harm that there's no way to help the person overall. You hope you can help them in enough time. So then we get to one that I think students always find fascinating, which is cloning. And I think a lot of times we think of cloning like these human armies of these clones that you can't kill them, and they are going out there and they're like these perfect humans. But cloning really has a wide range of effects, and cloning occurs right now, but just in different ways. Maybe we're not making an exact clone of me so that I can kill them off and take their pancreas and then be cured. Cloning can also be just cloning a single gene. It could be cloning an organ. Like if you've ever seen that picture of the mouse that has the human ear growing on it, that they then transplant the ear to the human. You could clone organs. Or what if they could grow me a pancreas in a test tube? Or what if like this amazing they out there, what if scientists could grow just the cells that were deficient in making insulin for me, and then they could transfer them into my body and I could be cured? Do they have to make just those cells, or do they make a whole organ, Or is this the fountain of youth where we can make new cells to replace dying cells and then be able to live on forever? There's all kinds of promises, but there's also all kinds of perils. So one of the most famous cases of cloning was Dolly the sheep. And Dolly the sheep was like the first big mammal that was able to be cloned. So what they did in Dolly the sheep was they took an egg cell from one sheep and then a mammary cell from another sheep. They removed the nucleus from the egg cell and they fused those cells together. So they basically took the nucleus of one cell and put it into this donor egg cell. And then they initiated cell division, and that little symbol right there is with a jolt of energy. So perfect in time for Halloween, like Frankenstein, where they jolt him with electricity and he comes alive. That's what's happening here. So then they jolted it and it started dividing. The one cell turned into two cells turned into four into 8. So they grew this embryo and they put it into the uterus of a surrogate mother sheep, and then the surrogate mother gives birth to this clone sheep, and that was Dolly, and that happened in what year? Is it in the book? Is it in there what year it happened? I don't know why I'm thinking 1996, but that seems like that was pretty long ago. Maybe 2003. Does anybody know what year Dolly got cloned? Or 1996. Okay, I was right with my first guess. Okay, so she was born then. Now, imagine how many times they had to screw this up before they actually made it happen. And then, once they actually made this happen, Dolly only lived 6 years, and a normal sheep lives to be something like 20 years old. And so, Dolly dies early, and she goes through this progression like very, very fast. So, she ages very, very quickly and dies very, very soon. And so we're going to talk a little bit about why cells can't live on forever. But the interesting thing to think of here is if they made this sheep, then at what point are they going to produce a human? And if they clone a human and they know that Dolly the sheep, like their efforts in cloning sheep were so difficult and so many sheep died and came out deformed and that Dolly died early. I mean, she could have lived to be 20 years old. She only lived to be 6. So if we clone a human and humans can live to be 80 years old and the clone dies when it's 15, like, is that an ethical thing to do, playing with life like that? I think it's a really fascinating question, and I will say there's no proof that this is true, but I'm sure they've done it already. I'm sure that they have cloned a human already. Somewhere at one of those countries around the world, they've done it. Because you know there's been all kinds of ethical, horribly unethical experiments that go on out there. Probably in in South Africa somewhere or in the Middle East somewhere. They've done this. We just haven't heard about it yet, but I'm sure that we will soon.